Hello, this is the luckiest maths teacher in the world. Thank you so much for tuning in, and today we're going to go through probability and we're going to have an emphasis on complementary events. So let's first have a recap of what probability is. So we'll start with a number line that you've seen many times before. So this is going to be the number line segment between 0 and 1. So of course halfway between them is the number half, or 0.5. So probability is the mathematics in which we assign to an event a number between 0 and 1 to indicate how likely it is. We give an event a number that tells us whether it's likely or unlikely to occur. So obviously, as we go on, events are becoming more and more likely. So the higher the number we give to the event, the more likely it is to occur. But we always, in probability, have to give a number between 0 and 1. So at the right-hand extreme of 1, an event we say is certain. So an event with probability 1 is certain. If we give an event the probability 1, if we assign to it the number 1, it means that that event is certain. Of course, if we assign number half, then it's an even chance. It's just as likely to occur as it is to not occur. And of course, an event to which we assign the number 0 is impossible. There is absolutely no way it can happen. And as we're going towards the left, events are becoming more and more unlikely. So if an event has a probability close to 0, it's more likely that it will not happen. So we can write probabilities as fractions, decimals, or percentages. It doesn't matter. Of course, 1 is the same as 100%. Even chance, probability of a half has a 50% chance of occurring. And 0 is, of course, the same as 0%. Okay? So we learnt earlier, you would have come across this formula, that the way we can assign a number to an event, indicate its likelihood, we have PE, which means the probability of an event is the number of ways that the event can occur over the total number of outcomes. So another way of saying total number of outcomes is the number of events in the sample space. Now, it's important that we understand we can only use this formula when all events in the sample space, so when all possible events are equally likely to occur. Okay, so let's have a look at an example. So let's say I roll a normal 6-sided die. So the probability that I would roll a 5, well, there's 1 5 on the die, so there's one way that the event can occur out of 6 outcomes in total. So if I rolled another die and I wanted to find the probability that I get, say, an even number. So there are 3 ways that can occur. I can get a 2, a 4, or a 6, and there are 6 outcomes in total, so it's 3 over 6 or a half, 0.5. And I can use this formula here because when I roll a die, all outcomes are equally likely. Getting a 1 is the same chance of getting a 2, getting a 3, and so on. So now we need to take a look at complementary events. So the complement of any event is simply that event not happening. So there's a special rule that links the probability of an event with the probability that the event does not happen. So not only do probabilities have to be between 0 and 1, probabilities always sum to 1. The sum of the probabilities of the events in a sample space always adds to 1. So for example, let's say I roll a die. So I know that there are 6 events in the sample space. I can get a 1, and the probability of that is a 6th. Probability that I get a 2 is a 6th. Probability I get a 3, and they're all the same. And I go all the way up to 6. I can get any of the numbers between 1 and 6. So what we know here, all of these add up to 1. 1/6 plus itself 6 times gives me 1. So the sum of the probabilities of all the possible outcomes equals 1. Just like when you toss a coin, probability of heads is a half, probability of tails is a half, and a half plus a half equals 1. If I'm looking at the suit of a card I pick from a deck, there are 4 possibilities: hearts, diamonds, clubs, or spades. Each of them has probability of a quarter. So if I add all of those up, if I add a quarter up 4 times, I get 1. So the sum of the probabilities of all the possible events, all the events in the sample space that is, always equals 1. So because of that, if the probability of an event is a number, say x, the probability that that event does not happen is 1 minus x. So, of course, if the probability of an event is x, x has to be a number between 0 and 1. So this number 1 minus x can never be negative. So remember, the complement is just the event not happening. So I know, for example, the probability, if I roll a normal die, the probability I get a 1 is 1/6. The complement of that event, I usually write with a dash there, which means not. The probability I don't get a 1, I could get a 2, 3, 4, 5, or 6. So there are 5 options out of the 6 total outcomes. 1/6 plus 5/6 equals 1. So the sum of the probability of an event and the probability of the event's complement is always 1. If I add the probability of an event happening and the probability the event doesn't happen, I always get 1. So another example I gave you earlier, so the probability if I roll a die that I get an even number is a half. So the probability that I do not get an even number, i.e. that I get an odd number, is just 1 minus a half, which is also a half. So we've got to make sure that we're careful. Sometimes people confuse complement event with the opposite, and that isn't always the case. So let's take a look at an example. So if I let A be the event that my soccer team wins on the weekend, so that I might be able to find the probability of it. The complement of that event, which I'll put A dash, which means not A, it doesn't mean my soccer team loses, it means my soccer team does not win, and they're not the same thing, because my soccer team does not win also includes the possibility that I draw. Okay? So, if the event A is my soccer team wins, the complement of that is my soccer team doesn't win. If I have the event it rains today, the complement of that event is that it doesn't rain today. So if, say, the probability that it rains today is 0.3, the probability that it does not rain, which I write like that, is just 1 minus 0.3, which is 0.7. This makes sense. It's just like percentages, you know? If you have a test and you answered 45% of questions correctly, you answered 55% of questions incorrectly. Because probabilities add to 1 in exactly the same way percentages add to 100%. So if you've won 30% of your matches, that means you have not won 70% of your matches. So if the probability of your team winning is 30% or 0.3, the probability that you don't win is 70% or 0.7, okay? So to find the probability that an event does not happen, you just subtract the probability it does happen from 1. Please ask if I haven't been clear on anything. This has been the luckiest maths teacher in the world. Have a great day.